Today we're going to be interpreting the slope and the y-intercept. So to begin with, Hong is a software salesman. Y is going to represent his total pay, and X is going to represent the number of copies of Math is Fun that he sells. Suppose X and Y are related by the equation Y equals 1,500 plus 120X, and answer the questions below. Notice that if a change is increasing or decreasing, that's going to give me a different coefficient. So if it's increasing, it's positive. If it's decreasing, it's negative. All right, the first question asks, what is the change in Hong's total pay for each copy of Math is Fun that he sells? Now, my answer is going to come from the equation that I use to represent the relationship. Now I have two numbers, 1,500 and 120. 1,500 does not have a variable with it, meaning it's my y-intercept or my starting value. $120 has a variable with it, meaning it's my slope, or in other words, it's my rate of change. So as I go back to the question and it asks, what is the change in Hong's total pay for each copy of Math is Fun he sells? Well, notice it's the rate of change. So 120 is my change for each copy that he sells. So my answer is 120 for the first part. What is Hong's total pay if he doesn't sell any copies of Math is Fun? Okay, well, if I don't times this by 1 for selling one copy or 2 for selling 2 copies, he just is going to start with his starting value, which is 1,500. Let's look at another similar example. Salma is putting money into a checking account. Let Y represent the total amount in the account, and X is the number of weeks that Salma has been adding money. Suppose that X and Y are related by the following equation. What is the change per week in the amount of money in the account? Well, remember, change is my slope, and slope is always next to X because that's what I will be adding repeatedly. And I can plug something in for 2 for how many times I'm going to add 20. So my rate of change, or my change per week, is $20. And what's the starting amount in the account? Well, I'm adding 20 to 650, which is my starting amount. Raphael stepped onto the escalator, moving at a constant rate. The table below shows his distance from the first floor after different amounts of time. So 6 seconds, he was at 1,070, 9 seconds, 980. Well, notice that what's happening is that this is a decrease, this is a decrease, this is a decrease. So as more time goes on, his height is decreasing, meaning when he steps on his escalator, he's going down instead of up. So let's answer the first question. Choose a statement that best describes how the time and his distance from the first floor are related. So time is increasing for both of these options, and it is here, plus 3, plus 3, plus 3. Okay, but what's happening to the distance? The distance is decreasing. So I would choose this option right here, and we're going to answer the follow-up question. At what rate, remember that's my slope, is the distance from the first floor decreasing? So if I'm finding slope, remember that an input and output gives me an ordered pair. So 6, 1070, and 9, 980 are my 2 of my ordered pairs. And I choose this 2 smallest so that I have refers to just by random choice. So let's go ahead and subtract. 980 is my second Y value, minus 1070 over 9 minus 6. Well, 980 minus 1070 is negative 90, and 9 minus 6 is 3. If I simplify my slope, that gives me an M of negative 30. Now notice this centimeters per second. You might be tempted to put negative 30 because that's my slope, but remember they asked how much it was decreasing. So we're already taking that negative into account, and my answer is just going to be 30. I'm decreasing by 30 centimeters per second. All right, next question, B. What was Raphael's distance from the first floor when he stepped onto the escalator? Now there's many ways to reason through this. But I'm going to show you the most commonly used method, and it is my B method. Okay, I know that if I had an equation, it would be y equals negative 30x plus b. And b is what I want to find. I want to know when he stepped, how high he was when he stepped on the escalator. That's my y-intercept. So if I input an ordered pair, so let's input this first ordered pair, I should be able to determine what that y-intercept is by working backwards. Negative 30 times 6. So for 6 seconds, I was going down by 30, and I ended up at 1070. So to simplify, negative 180 plus b is equal to 1070, and solve. So plus 180 gives me a grand total of 1,250. So 1,250. Excuse me. Let's see a similar problem. Ivana deposits the same amount of money into a bank account every month. The table shows the amount of money after different certain times. So at 6 months, 423. And at 8 months, 533. Let's calculate the rate of change. Now, as I notice that as the time goes on, this is also increasing. So I'm going to make sure I choose the option as time increases, the amount of money in the account also increases. So 533 minus 423 divided by 8 minus 6. So 533 minus 423 is 110. 8 minus 6 is 2. And simplified, 110 divided by 2 is 55. So my change is $55 per month. Now, how much money was in the account when she started depositing? Well, I want to find my y-intercept. I need to go backwards in my table. So again, I'm going to use the B method. I know that the relationship is given by 55x plus my starting value. So plug in one of my points. 423 is equal to 55 times 6. Now, if I had to guess, I'm confident that it's going to be smaller than 423. So 55 times 6 means she added $330 to her account in the 6 months. And if I want to find my y-intercept, I'm going to subtract that 330, and I can figure out how much is left in there. So 423 minus 330 equals a grand total of $93. So $93.